This is a part of the problem with the current technology, that you can't rely on it, that it has the limitations. It doesn't know what it doesn't know. It can't really think about its own thinking very well at all. And so the lack of intelligence or the limitations of its intelligence actually is what make it dangerous.
Welcome to the Agile Digital Transformation Podcast, where we explore different aspects of digital transformation and digital experience with your host, Tim Butera, Content and Community Manager at AgileDrop.
Hello, everyone. Thanks for tuning in. I'm joined today by returning guest Peter Voss, CEO and Chief Scientist of the advanced chatbot platform Aigo, with whom we already had an awesome conversation about artificial general intelligence, AGI, and whether or not humanity is ready for it. And in today's episode, we'll be talking about what's missing in modern AI systems, and Peter will share his key lessons learned from actually creating a chatbot. So, Peter, welcome back to the show. It's great having you back. I remember that our conversation last time was particularly insightful, particularly engaging, and I think we're in for another great one today.
Yes, Theo, thanks for having me again. It definitely was fun.
Yeah, as we said last time, the field of AI is developing so quickly that there's always something to discuss. There's always something new to talk about, and yeah, let's get right down to business, Peter. And before we discuss what's actually missing in AI today, I want to first devote a little bit of time to discussing what AI is getting right today. So, what are some examples of good AI uses and implementations that you'd really highlight here?
Yes, as you say that, the field is moving very fast. And I mean, it's only been a few months since we last spoke, and so much has happened. The explosion of what's called large language models, like ChatGPT, it's really quite revolutionary. I don't think, I haven't come across a single AI researcher who wasn't really amazed and blown away by just how much these relatively simple systems can do. I mean, they're simple from an engineering point of view in terms that they don't have a very complex architecture. It's just masses and masses amounts of data and computing power. I mean, these models can cost $100 million to train, and just what it costs to do the actual computation. But the actual underlying technology and architectures is not that complex. So we really didn't expect them to be able to do as much as they can, to have such fluid conversations and language, and to be able to solve math problems and help with programming and, all sorts of things. So really the world of large language models has now been expanded to visual systems, creating images, and those are amazing, and even starting to create videos and voice. So I think from a creative point of view, this is really phenomenal. And, there are many, many use cases to give you ideas, to create copy, to create images, have poems, help you with email, with essays, and so on. So there's definitely a lot going on. Now we can talk about the limitations of them, but I think really everybody should start to use these tools and see where they are useful to them and how they can use them. So that has really been a big change in the last 6 to 12 months.
So we're really, as we also discussed in our first conversation, where we discussed the sparks of artificial general intelligence paper from Microsoft researchers, they highlighted a lot of areas of progress that they really, really didn't expect and couldn't anticipate, such as using tools, using calculators and stuff like that to kind of help with the computation and everything. And it really seems like we have, obviously, on the one hand, we have this unexpected progress in the context of AI getting things right, but you just said that we can also discuss the limitations of AI. And well, obviously, the main topic of our conversation today is what's missing in today's artificial intelligence. So obviously, we need to discuss this too, because it's not just unexpected progress, but there's also probably the other side. So where do modern AI systems fail, and what's the missing piece to kind of unlocking this power of artificial intelligence in a responsible way?
Yes, I think, because we're all so blown away, everybody's so blown away by what it can do, that it sort of exceeded expectations so much, that I think there's a sort of general sense that people overshoot now and, expect that, well, wow, this feels like human level intelligence. And I think that's starting to sort of, reality is starting to set in as people try to use them for more advanced or more critical applications. And so there are a number of inherent limitations in this technology. And I'll be talking more as we go forward. I'll be talking more about the difference between what's now called generative AI, which is a subset of statistical AI. So statistical AI or generative AI, which is really what this is all about, versus cognitive AI, which is ultimately what we need to have human level intelligence. So the current technology, I mean, ChatGPT, the word GPT already gives you some important clues. G means generative, which basically means they make up stuff. And
Yeah.
for better and for worse, they can be very creative in creating poems and songs and email and so on, but they can also make up stuff that is just completely wrong, completely bogus. And the problem is they do it with such confidence that it's very hard to tell. So if I've been using it for programming, for example, and I might ask it, how does this work, or can I do this, or can I do that? And it might give me an answer, might give me like 10 times when I use it, 8 times it might be really useful information, and twice it might be information that sounds extremely plausible, but it's just plain wrong. So the generative part is an inherent feature of it. It has masses of amounts of information, but that information wasn't curated. It's just scraped from all over the internet, good and bad. So there's a lot of garbage in the training, and the way it puts together even good information can just be wrong, that the combination of things may just not be true. So the generative part is both a strength and a weakness, but it's inherent in the approach. So you can never really rely on the information. There always needs to be a human in the loop and human level intelligence to say, better double check this. This doesn't sound quite right. So the second part, the P in GPT, is pre-trained. And that's the other huge limitation of the system, that all of the capabilities that it has, that are inherent in it, were trained, as I mentioned, can cost 100 million or more to train this model, but it's read only. Once the model is trained, the model itself is not actually adjusted, so it cannot learn additional things, or it cannot correct its knowledge, except for some sort of short-term tricks that they've worked out. But the inherent model is pre-trained, and it cannot learn and adjust and adapt to new things. That's why ChatGPT will tell you, since the information is up to date, up to the training date of September 2022 or whatever date it gives. Now, there are ways of using short-term buffers that you can give it additional information, but that information that you give it in the prompts that you might stack up is not fully integrated into the system, and it's not permanent. It doesn't change the actual core training of the system. So the pre-training is basically, it makes it that it's not adaptive, and it cannot really learn incrementally as you go on. Now, that's crucial for any, if you had a human assistant, you have a new business partner, you have a new product, you have, things happen in the world. You need to basically take that information and integrate it, and it becomes part of your current knowledge, and it may completely reverse knowledge that you had previously. So I think those are two critical components. The other one is the sheer cost of running these systems, that they require so much processing power, is and so much requires so much data. I mean, I don't know if we spoke about that last time, but a child, you can show a child a single picture of an elephant, and it'll be able to recognize, pink elephants and sideways and upside down elephants and so on, was just, one example. Whereas with statistical AI and generative AI, you basically need hundreds or thousands of instances for it to be able to learn. So the sheer cost of giving it new information is very, very substantial, and that also limits its application. How quickly it can potentially learn something new, or how many examples it needs to be able to learn. So those are and those limitations are inherent. That's why I say there's what DARPA, I think we spoke about it the last time, where DARPA identified 3 waves of AI. The first wave being sort of good old-fashioned AI, what all the expert systems and logic-based systems in the 70s, 80s, 90s. And the second wave is really that we're riding right now is big data, big compute, statistical systems, generative systems. But we ultimately need to move to cognitive AI that can think and learn and reason more the way humans do, and that are not pre-trained, or not only pre-trained, and that are not just generative in the sense of just making up stuff from statistical correlations, but can really think about and understand what they're doing and saying.
So yeah, this is the human level intelligence AI that we also kind of spoke about last time. We basically, if I remember correctly, we said that in order for AGI to be possible and to actually be beneficial to humanity, human level intelligence would basically be a necessity.
Correct, because and in fact, this is a part of the problem with the current technology, that you can't rely on it, that it has the limitations. It doesn't know what it doesn't know. It can't really think about its own thinking very well at all. And so the lack of intelligence, or the limitations of its intelligence, actually is what make it dangerous, or more dangerous. You want more intelligence for the system not to make mistakes that a human wouldn't make, or a human wouldn't make if they thought things through properly. I mean, we obviously make a lot of mistakes, but many of the mistakes we make is because we don't think about things carefully enough. We don't take enough data into consideration, or just have emotional reactions or so on. But an AI that really can think very clearly will not make silly mistakes. So I can talk a little bit more about the limitations. We are, as we're talking to corporate clients, large corporations and universities and so on, and how they use ChatGPT and large language models, is many of them have actually decided that they cannot use this for any critical applications, that the human always has to be in the loop. So, for FAQs, to help you find things on your website, from all the different documents and things like that, to obviously create ideas, to maybe fine tune an article or an email that you're writing, that's all okay. But anything where there's potentially legal liability or marketing issues involved, marketing department won't sign off on it without a human being in the loop, and the legal department won't sign off. So you cannot rely on the output of these systems. And that's sort of the general consensus, that for anything critical, you really cannot just use ChatGPT without a human in the loop.
But if we had human level intelligence, would this change? So specifically, if we had human level intelligence, would this make us do away with the need for a human in the loop if the AI kind of checking other AI tools such as ChatGPT and other LLM tools would actually have the same kind of cognitive functioning as a human?
Yes, absolutely. I mean, that's really what AGI means, is that you have human level intelligence. In fact, in many ways, it will be superhuman, because, it'll have photographic memory. It'll be able to actually reason better than humans can. But in terms of when we trust them and how we trust them, that really wouldn't be that different from what humans do you trust. I mean, when you have relationships, whether it's personal relationships or business relationships, you interact with somebody, if it's an employee, you might give them certain tasks, or a vendor, a supplier of something, somebody that, I don't know, to build something for you. You might give them a small project, and then you kind of build up confidence, and reputation. Somebody tells you, yes, this person is really good. You look at the resume. So it's all of these kind of things that you have to build up a reputation for, saying, yes, I can rely on this person or on this AI to do this particular job. And AIs can obviously cross-check each other as well. So it'll be a lot easier to do that kind of quality assurance really on AIs. But we need to get there. We need to get to that human level AI, which really requires a fundamentally different approach from the big data generative AI to actually achieve that kind of intelligence.
And what kind of approach would that be? Can you tell us a little bit more about this other approach?
Yes, certainly. So that field or that approach is called cognitive AI. And what that really means is, cognition, thinking, intelligence, the things to do with how the mind works and how the human mind works in particular. So the starting point for that is not how much data do we have or how much computing power do we have, and what particular problem can we solve. The starting point is to say, what does intelligence require? What are the components? What are the attributes that you need in intelligence? And one of the things, I mean, there are quite a number of, there's sort of a checklist. And I've written a number of papers on that, but there's a checklist, and one of them is that the system absolutely needs to be able to learn incrementally in real time. It needs to be able to take in information, new information, and integrate that with whatever it already knows. And that has to be a process that can happen in real time, because things can happen very quickly. You may need to, you need to make decisions. If you're learning a new tool, you need to experiment with that, maybe try a few different things, and okay, you get the hang of it, you can now use the tool. You might have a conversation, you might get an email, you might talk to somebody that gives you new information that changes direction. So being able to learn interactively in real time without having unlimited computing power or something, because there's no such thing as unlimited. So the system has to inherently be designed to do that. It needs to have short-term memory, it needs to have long-term memory, it needs to have context, and needs to have deep reasoning ability. And the reasoning ability needs to include being able to think about its thinking, or what's called metacognition. So it needs to be able to reflect on its own thought process and say, am I approaching this in the right way? Am I thinking about this the right way, to sort of to direct the thought processes? So the architecture of the system, the way it's designed, needs to be designed to be able to do that. Another element is to be able to form abstractions, which is really the key thing that separates us from animals, is that we are able to form very abstract concepts, that we can form abstractions on top of abstractions on top of abstractions. And that is unique in humans, where we can learn, obviously, the instances of different people and different animals that we come across, but then we can put them into categories, saying this is a human, this is a cat, this is a dog, and this is a pet, and this is a wild animal. And then we can have levels of abstractions that can go as far as, concepts like honor or marriage or government, or, things like that that are quite abstract. So the system needs to inherently be able to form these concepts automatically. They can't just be force-fed from sort of external sources. The system needs to be able to form new concepts. And this is how really deep understanding happens. That's how innovation happens, is when when we put a number of different things together in a new insight and a new kind of abstract representation. So there's sort of a very different approach, saying, starting with what does intelligence require, and then you build a system that allows you to create, that has all of the capabilities that you need for intelligence.
And I'm betting that you implemented all of these, or the ones that you didn't implement while creating Aigo, you probably learned while creating Aigo. So can you tell us a little bit more about that, about how you created Aigo, so the advanced chatbot, and what were your key findings, key lessons learned from this entire process?
Yes, absolutely. So, Aigo, our current product, we call it a chatbot with a brain.
Mm-hmm.
And that's really to make the distinction between every other chatbot out there, which doesn't have a brain. And, we often can, as we interact with chatbots or call into a company and deal with an automated system, more often than not, they are pretty bad. They really don't understand what you want. And then if the conversation changes, they don't remember what you said earlier. So what our approach is to have cognitive AI, to have a brain, to have a system, a computer system that has memory, that has reasoning, that has deep understanding, that uses context to be able to hold a conversation, a much more elaborate conversation, and with deeper understanding. And we've been working on this for 20 years. So we've gone through long stretches of just pure development, because it's not a trivial problem to solve, to build an artificial brain. But we now have a product that's still quite a long way from human level understanding and knowledge. One of the big problems is giving the system enough common sense knowledge, the knowledge that we automatically pick up just by interacting with the world, growing up in the real world. That's quite challenging. So right now, the applications we have tend to be focused on solving a particular, we train the system to solve a particular set of problems. So an example is one of our clients is 1-800-Flowers. And it's a group of companies, where Harry and David and Popcorn Factory and so on, very, very, very big company. And our chatbot basically gives a hyper-personalized concierge type service to their 20 million customers, where it remembers the kind of things that they like to buy, what gifts they buy, whom they buy it for. It remembers previous conversations you've had, so it can be more proactive about that. So those are the kinds of applications we do with our technology right now. But we just, in fact, since we last spoke in the last few months, we have launched a new project to build a separate team that will concentrate on taking our technology to the next level, and having a sort of a big concentrated drive to get much closer to human level intelligence, which is, that development is happening in parallel with our commercial implementations, which are using the sort of proven technology that we have. But on the development side, we are, doing more radical changes to really rapidly get closer to human level intelligence. So we are currently in the process of expanding that and building that team, so to finally get to true human level intelligence.
And so what has been kind of your number one finding, maybe something that you didn't expect when you started developing this, when you maybe, I don't know, also I assume that you must have had some special reasons for forming this more radical development team. Can we talk a little bit more about this also?
Yes, certainly. In fact, it's exactly the success of ChatGPT that has sort of been the catalyst in that. And there are a number of factors there. The one is, a lot of people now feel much more optimistic about achieving human level AI. We can talk about the risks and the concerns about it, but there's a general sense, hey, we may not be that far off. That just what ChatGPT is showing us, that maybe we can build these systems after all, and not in 100 years or 1,000 years, but maybe more in like 5 or 10 years. So I think there's a large amount of optimism in terms of being able to achieve human level AI sooner rather than later. And that, of course, also has an influx of money. VCs are pouring billions, tens, hundreds of billions dollars into the technology. So there is this sort of the environment is very much pro AI development right now, and getting closer to human level AI. So that has changed from, say, a year ago, where there's more optimism and more people are interested in getting into the field, into development. But the second thing, specifically for us, that has motivated our concerted push now is, as I mentioned earlier, one of the difficulties is getting enough common sense knowledge into our brain. Previously, I always estimated that it would take thousands of people to gather this information and teach Aigo that. Just as a reference, Amazon had 15,000 people working on Alexa. Now, they've actually not quite shut down Alexa, but they very, very significantly scaled down the whole Alexa effort. I think they realized they're kind of not really making progress on the approach that we're using. But anyway, that was my concern, that it would take thousands of people, and we simply don't have the resources in our company right now to do that. Now, with large language models being around, we can combine the reasoning ability that we have and sort of the inherent quality assurance that our system can do, but utilize the knowledge that is embedded in large language models to train our system. So the cost of training our system has reduced very, very significantly with these large language models and sources that are available now. So the combination of, on the one hand, the much bigger interest and momentum in the field of AI, combined with the ability to train our system much, much cheaper, has really, well, we've got to jump on that. And just so we're in the process of building a team, a separate team right now, using some of our existing people that have been with us for many years and have a lot of core knowledge, of course, but then also expanding the team to get to human level AI as soon as possible.
And yeah, since you mentioned, what would be some main concerns of achieving human level intelligence that you just said, that we can also discuss this a little bit?
Yes. So I don't really buy into the whole thing that AI may want to kill us or something, take over the world. I see absolutely no evidence that the kind of systems that we're building that are designed specifically to help humans. I mean, that's what they are, assistants to us, and that's their inherent design and motivation. Now, it's obviously a long debate, and a lot of very smart people are quite concerned about AIs because of having a mind of their own and their own agenda, and that humans will just be treated like we treat ants. As I say, I think mainly that's coming from people who have just a theoretical approach from it, and they've sort of thought themselves into a particular corner. I think when you actually work with these systems and how you design them, it's anyway, for both theoretical and practical reasons, I don't have that concern. Now, of course, it will be very, very disruptive generally in terms of human society, but mainly in a very positive way. But let me give you the one sort of typical example that I give is, imagine training up one AGI as a cancer researcher, PhD level cancer researcher. So you now have this AGI, this Aigo or whatever, that can do cancer research. Now you make 1 million copies of that AI. You have 1 million PhD level cancer researchers chipping away at that problem. And you take that same idea now and apply it to problems with designing better batteries, nanotechnology, dealing with pollution, cleanup, with poverty. I mean, every problem that faces humanity, we will be able to throw massive amounts of intelligence at helping us solve the problems, including governance, and how we manage our affairs as a society to come up with better ideas that will just improve human flourishing. So I see massive advantages in having AI. Now, of course, when AIs can really truly do many human jobs, those jobs will be replaced. Now, people, there's one part of us that says, well, that's really terrible. But let's flip that on its head and say, how many people do you know that would not want to win the lottery? I
Yeah,
mean,
yeah,
almost everybody wants to win the lottery. And AGI really is like everybody winning a lottery,
yeah,
because there will be so much wealth created that we will not have to work. So you can do the things, you can work on the things that you want to work on, not the things you have to work on to make a living. So there's just tremendous upside. But the adjustment for people to win the lottery, of course, will be traumatic for many people. I mean, we know a lot of people don't cope that well with suddenly not having to work anymore.
yeah.
So again, AI can help us get through that period, in terms of helping us to find the best way that we can motivate ourselves and enjoy the freedom that we'll have.
Yeah, I remember we also discussed this analogy with winning the lottery last time,
Mm,
and kind of also highlighted the
mhm.
potentially negative aspect of it. I think you pointed out that a lot of lottery winners actually end up reporting a decrease in their happiness and kind of comfort and well-being,
Yeah,
as opposed to an increase. So yeah,
yeah.
there's definitely a lot to consider here.
That'll be a new problem we have to solve. But as one might say, well, that's a nice problem to have.
Yeah, yeah, true. Well, Peter, thanks for another great conversation. I'm really glad we got you back for another one. Before we jump off the call, if people would like to reach out or connect with you, what's the best place for them to do that?
Well, Aigo.ai. You can email me, peter@aigo.ai, but I'm also on LinkedIn, on Twitter, Facebook. So not hard to get hold of me, whatever the sort of medium you prefer. And I always welcome ideas, questions, and collaborations. And we definitely right now looking for people who want to join us on our journey to actually finally build AGI, to build human level AI. So whether they are investors or technology people or people who want to use our technology right now in their business.
Well, I certainly hope someone takes you up on your offer, Peter, and gets in touch with you about that. And yes, thanks again, Peter, and have an awesome day.
Yes, thank you.
Well, to our listeners, that's all for this episode. Have a great day, everyone, and stay safe.
Thanks for tuning in. If you'd like to check out our other episodes, you can find all of them at agiledrop.com/podcast, as well as on all the most popular podcasting platforms. Make sure to subscribe so you don't miss any new episodes, and don't forget to share the podcast with your friends and colleagues.